So here we are with a short video on how to make an adjacency matrix. Now this is a topic of graph theory. So we'll start off with this example that we looked at as our first graph in the previous video. And we'll make a simple adjacency matrix on this. So an adjacency matrix is basically a grid of numbers that represents the connections between every pair of vertices. So here's how we go about filling this out. I've sort of drawn the grid here, and we're going to start with the A on the left-hand side and compare it to each of the vertexes at the top of the matrix. So we'll start with this A to A, and because we're working with directed graphs, we want to know, is there a path from A to A? And that we would be looking for one of these curved paths, and there's not. So because there's no path, we're going to write 0 at this position in the adjacency matrix. Then we want to see, is there a path from A to B? So can we get from A to B following this edge? So I'm looking for this edge, and I'm looking for the arrowhead on the end to say that I can travel in that direction. And it is there. So yes, path. When that's the case, we'll put a 1 in that position in the adjacency matrix. And then let's look at A to C. From A to C, there's nothing, so we'll put in another 0. Then we move on to the second. So we're always going to start on the left side of our adjacency matrix to do our comparison. So this is the from side, and this is the to side. So from B to A, can we make that transit? From B, there is the edge, and there is the arrowhead indicating that I can go in that direction. So B to A is a 1. B to B, there is no such path. And B to C, so here's where the direction and our from and to ends are important. So from B to C, there is an edge that allows travel in that direction. So that's a 1. Now let's look at our last one, C to A. There's nothing. From C to B, again, now there is an edge, but we can't travel in that direction along the edge because it's a directed edge. So that would be just a 0. It's as if there was no edge at all. And C to C, there is no edge. So that's it. This is our adjacency matrix for this simple graph. And this is a skill that you're going to need to solve ACSL problems, creating an adjacency matrix. So let's try this now on the second graph from the last video series. This one's a little more complex, so there's a lot more to work out here. I won't talk through every step, but I'll do a quick demo of how we'd go about solving this. So I'm going to start on my from side of my matrix here, and the top is the 2. So we'll fill this out row by row. So we'll look at from A to all the other options, then we'll go from B to all the other options, and so on. So from A to A, that's a 0. From A to B, 1. Well, at this point, I can see that there's no connections from A to anything else. So A to C is a no, A to D is a no, and A to E is a no. Good. So B to A, that's a yes. There's an edge, and I can travel in that direction. B to B, no. B to C, yes. B to D, direction's important, so that's a no. And B to E, no. So let's see. Now we're on row C here. So from C to A, no. From C to B, direction's important, so that's a no. From C to C, no. C to D, that's a yes. And C to E, no. Now this is interesting. Look at this so far. So if you're at node A, terminology-wise, sometimes these are called nodes. ACSL calls them vertices or vertex. And I think in my training and upbringing, I've always called them nodes. So you can use those words interchangeably, and I will probably just forget and call them nodes. So I'm talking about vertices when I say that. From A, I can, if I look at the A row in my adjacency matrix, I can see that there's only 1 in this row. So that means I can only travel from A to one other node. I'm locked in. If I'm at A, I can only get to B. And we can see the same thing in row C here. If I'm ever on node C, I can only get to D. And that should carry out if we look on the graph diagram itself. So there's A. From A, the only direction I can go is this way to arrive at B. If I'm on C, the only place I can get to is D. And you could do a similar exercise from looking at the top, right? So can I get to this node from another one? So on, but I'm not going to go through that right now. So let's just go back and finish up this matrix. So D to A is a no, whoop, screen flicker. D to B is a yes. D to C is a yes. D to D, no. D to E, yes. And then from E, this is the tough one, right? E to A, no. E to B, no. C, no. D, no. Once you're at E, the only place you can go is E. Sounds like Hotel California or something like that. Okay. Have a nice time working with adjacency matrices. Matrices is the plural of a matrix. So we've drawn one adjacency matrix here, and in this video, we've done 2 adjacency matrices. Have fun with those. I think that's everything you need to know. Bye.